guys, today we're going to learn about different rational numbers. Alright, so our objective is to classify numbers, which basically means to identify and name what type of number each one is. And this is page 13. Alright, so here is a little bubble diagram of different types of numbers. We have natural numbers, whole numbers, integers, and rational numbers. Okay, so first of all, I'm going to give you some examples, and you're going to have to write small because we got a lot to fit in. So, an example of a natural number, those are your counting numbers. So 1, 2, 3, etc. Goes on infinite, okay? Whole numbers are actually all these natural numbers, but we also include 0. So natural numbers, 0 doesn't count. Whole numbers, you have 0 plus all the natural numbers. That's why the natural bubble is inside the whole number bubble, because all natural numbers are also whole numbers. Okay? Some examples of integers. Well, we just learned about integers, right? So we know that it's 0, 1, 2, 3, which are why this bubble is surrounding the others. But then it's also their opposites, the opposites of the whole numbers. So you'd have -1, -2, -3, etc. And then your rational numbers, those are going to be your fractions and decimals. Again, rational numbers are all of these that we've already discussed, plus the fractions and decimals. So, for example, 3.4 or -1/2. Rational numbers can be negative. Just because you see a negative doesn't make it an integer. Remember, integers are whole numbers and they're opposites. So fractions and decimals can only go to the outside. Okay, now the other thing we're going to squeeze in here is I'm going to sort of give you an analogy for what you can think of this as. Okay, so for example, we are at Huddleston. So the natural numbers is like being at your school. Okay, so this is Huddleston. Now, whole numbers would be like the next outside. So Huddleston is inside of Princeton. Princeton is inside of Texas. And Texas is inside of the United States. Okay, so let's kind of break this down why I'm using this analogy. If you are inside Huddleston, does that mean that you have to be in Princeton? Well, yes, Huddleston, all of Huddleston is in Princeton. So all natural numbers are also whole numbers. However, just because you're standing in Princeton does not mean you're at Huddleston. So that's why 0 is not a natural number, okay? So whole numbers are not necessarily natural. But if it's a natural, then it is a whole number because Huddleston will always be inside of Princeton. Okay, now let's look at Princeton versus Texas. If you are in Princeton, you are in Texas. So all whole numbers are also integers. But just because I'm standing in Texas doesn't mean I'm in Princeton, Texas. So just because it's an integer does not make it a whole number or a natural number. So for example, if I have the number -2, that would be like me being in Austin, Texas. Okay? I'm in Texas, so I'm an integer, but I'm not in Princeton or in Huddleston, so these would not count. All right? And then the last one, the United States. Okay, well, if I'm anywhere in Texas, I am in the United States. So all integers and whole numbers and natural numbers are also rational. That's why this bubble encompasses everything. However, if I'm in Florida, well, I'm not in Texas or Princeton or Huddleston. So Florida would be kind of like -1/2. It's a fraction or a decimal. Fractions and decimals, whether they're positive or negative, they do not go in Texas, Princeton, or Huddleston because they're not integers, whole numbers, or natural numbers. Okay, so you kind of think of it like that. Now, we're going to sort of use this analogy to help us answer these questions. So we're going to put either an A for always, an S for sometimes, or an N for never. All right? So read the statement And I want you to go ahead and just put what you think it is for now, looking at this, and then we'll discuss. So go ahead and pause and put A, S, or N in each blank. All right, so now we're back. Let's look at each statement and see how you did. And if you got it wrong, no big deal, just fix it on your paper. All right, integers are rational numbers. Well, let's use our analogy. Texas is in the US. Well, is Texas always inside the United States? Yes. So this should be an always. Okay? No matter what, Texas is always going to be inside the United States, so all integers will also be rational. Always. Okay, next one. Integers are positive. Well, if I look right here, I can see some negatives right here. Now, so I know it can't be always. However, I have to decide between these. Well, an integer, the definition of integer means any whole number and its opposite. Well, whole numbers are positive, and those are also integers. So if I'm in Princeton, I'm also in Texas, so they could be positive, but they don't have to be. I can have positive and negative integers. So this should be an S for sometimes. All right, next one. Fractions are integers. Well, if I look up here, fractions right out here. Just because I'm in the United States, does that mean I have to be in Texas? No, I could be anywhere else in the United States. So fractions are actually never integers. The integer, remember the definition, is a whole number and its opposite. So fractions and decimals are only belong to this rational bubble. So this would be a never. Okay? And the last one, whole numbers are more than 0. Well, a whole number can be 0, and 0 is not more than 0. So I know it can't be always, but Huddleston will always be in Princeton, so these are also whole numbers, so they can be more than 0. It's just not always. So this should be a sometimes. All right? So there you have it. Okay, next we're going to look at some numbers that I've placed here, and we're going to actually sort them into the bubbles where they go. Now notice right here I have whole numbers, and I've just taken out natural. Sometimes you might see these two bubbles combined into just whole numbers because the only difference between these two bubbles is the 0. So it's kind of unnecessary to always keep them separate. So when you only see 3 bubbles, you know that the middle bubble is actually whole numbers, which encompasses all the natural numbers anyway. Okay, so let's take, for example, -3. Well, can I put a negative inside whole numbers? No, because whole numbers are never negative, so it does not go here. How about integer? Well, actually, I see it right here, so I know that would make sense. So yes, I can put it right here. So -3, and I'm going to cross that out. Okay, we'll do one more together, and then I'll have you try the rest. Let's look at the number 0. Well, I see right here that whole numbers include 0. So a whole number, 0 is the first whole number. So I would put 0 here, and I can cross that out. Okay, so go ahead and pause and place the rest of these numbers where you think they might go. All right. Hopefully you've had time to place them all where they go, so let's go over it and see if I tricked you on a couple of them. Okay, we have 5. Well, a 5 would be like 1, 2, 3, 4, 5. It's a natural number, which also makes it a whole number, so we should have 5 in here. Okay, next one, 1/2. Well, I know fractions and decimals can only go out in the rational bubble, so you should have placed 1/2 in the rational. All right, I'm going to skip this one for now and jump to 8. 8, it's a whole number, so we've got to put it right here. All right, 0/2, again, I'm going to skip it for now and go to -6. Well, it's negative, so I know it can't go here, so that means it must go here. And -1/4, this is simplest form, so it's a fraction. Fractions cannot go in either one of these, so it has to be rational. The fact that it's negative doesn't matter. It's still rational. So negative 1/4. Now, let's look back at these two. The reason I skipped them is because these are two fractions that can actually be reduced. So this is how you might get tricked. If you have a fraction that can be reduced, you need to put it in simplest form before you identify what type of number it is. So if I reduce this, 4/2, I can divide by 2/2. And that would be negative, well, 4 divided by 2 is 2, and 2 divided by 2 is 1. Negative 2/1 is the same thing as negative 2. So negative 4/2, I would need to first reduce that to negative 2. Now you might have gotten tricked and put this as rational, but since I can reduce it to this, it's actually, it's still rational, but the better place where you need to put it would be integer. So this should go here. And again, I'm going to put, the reason is because it's equal to negative 2. Okay? So now let's look at the other one, 0/2. If you have 0 as your numerator over anything, it's just equal to 0. 0/2 equals 0. So again, you might have placed it on rational because it was a fraction, but remember, because it reduces to 0 or a whole number, 0/2 should actually go here because it's the same thing as 0. Okay? So, cross that out. Don't get tricked by that again. All right, now we're going to compare two integers. Again, just like when we compared two rational numbers. Just like when we compared positive rational numbers, we first changed them to decimals. So we need to first change them both to decimals. This is already decimal, so I just need to change this one. Now maybe by now you've started memorizing some of these more common benchmark fractions. If not, that's okay. You can always divide. So again, the negative 3 I don't have to change. I just need to divide 1/4. 4 goes into 10 twice, which is 8. 4 goes into 20 5 times. So negative 3.25. And this one, negative 3.2, and I'm going to go ahead and add a 0, don't forget that step, so that I can better compare them. Now, I need to think about this and be careful because they're both negative. If I had a number line, which I'm going to use this right here, 0, since these are both negative, 0 would be all the way over here. So now I should just think to myself, well, which of these is closer to the 0? Okay, well, 3.20 and 3.25. This one looks smaller, so it's going to be closer to the 0. So this one could go here. Again, you don't have to worry about putting in -1, -2, -3. We're just comparing these two. And this one would be a little further from the 0, so I'm going to put it a little further away out here. Okay, well, remember, when you're looking at a number line, the further a number is to the right, the larger it is. The further a number to the left, the smaller it is. So that makes this number smaller and this number larger. Well, that means, again, we have to think backwards with negatives. The smaller a number looks, the bigger the value. So this one is larger, so greater than. Okay, let's do the same thing here and make these into decimals. Now technically negative 3 is already a decimal because your decimal would just be at the end. This is already a decimal, so now I just need to change 5/2. Again, I know it's going to be negative, and I'll just divide the 5/2. So 2 goes into 5 twice. I know there's going to be a whole number because it's improper. Now I add a decimal and a 0. 2 goes into 10 5 times. All right, so that's negative 2.5. Then I have negative 2.8. And again, so I can better compare this, let's just add the 0, 3.0. Okay, again, I want to put these on my number line. So they're all negative, so I can imagine 0 way over here. Now, which of these is closest to the 0? Well, the one that looks the smallest would be the closest to the 0. So negative 2.5 would be closest. Negative 2.8 would be a little further away, and negative 3 would be the furthest away. All right? And let's say I'm doing this in ascending order. What does that mean? Least to greatest. Well, good news. If I put them least to greatest, they were already in order. So my order would be negative 3. Don't forget, put them in original form. Negative 2.8. Negative 5 halves. All right. And this is sort of a little preview of what we're going to learn next. So see you next time.